Good afternoon. On behalf of Resolution Engineering, which consists of Barry Lindmark, Lawrence Lee, Yi Su, and Jeff Eklund, and myself, Luke Ruskowski, we'd like to thank everyone for coming out. We'd also like to congratulate our fellow students on great designs and great presentations.
As you guys can see, this is our final design. We actually choose this is because they have a best balance between our design specifications. And the further detailed introduction for this individual system will be present in a later presentation. Because now I want to talk about some calculation first. In order to verify if we have met our design specifications, we have done all these calculations listed here. There's four main parts will be considered. The first one, like the base, and the force applicator, brackets, and the slider rail. In the base part, the deflection was considered the most because it actually contributed a lot to the error of the camber measurements. And for the rest of three parts, we only worry about like the bending moment, the shear stress, the well stress, and after doing the detailed calculations, we actually found out that all these parameters was within our requirements, but base deflection. Because the base deflection will actually be on a little bit too much. Because this is a problem here. We have to face like the problem. Like we need to balance the base deflection and the base weight. Because those two key elements was pretty crucial to our climb. So the solution for this problem, well, I will talk about in a little bit later. The first, for a system base, the base was made actually with two parts, the plane and a 2" by 4" aluminum tube beam. Here, the tube beam was connected by welding together, and the plane was bolted on the top of the beams. As I mentioned earlier, this is a problem actually for the deflection of the base here. The solution we did is we actually built a slider rail. As you can see here, slider rail on the beam defect the most. And then in that case, the beam and the camber measurement device will have the same amount of rotation together. So they will have a zero relative displacement to each other, which actually can help us to minimize the error in the camber measurements. And also, due to the complex loading conditions, we are forced to use a single point loading in our calculations. And the result we got for the deflection, 0.34 millimeters, is actually in a worst case scenario. So after that, all these analyses, we are pretty confident about the deflection when we calculate when we find the camber measurements, the result will be very accurate. And that's how we solve this problem.
So